Grade 12 Trigonometry, Mathematics Paper 2. Now, I've got a question here from the 2023 GDE prelim paper, the trial examination for 2023 paper 2, the section on trigonometry. So it was question number 5 in that particular paper. Right. I normally advise that when you are going through past examination papers, don't just go learn something. At the end of it, you must be able to say, okay, after going through this paper, I now remember A, B, C, D, or I now understand this particular item. Be able to pinpoint certain things that you have learned through from that revision. Then you can say your revision is being productive. A quick summary of what we are facing here. In question 1.1, we have a diagram. Now we need to know that this diagram, they can give you a drawn diagram like this, or they can ask you to draw your own diagram. So when I'm answering it, the point given at point P. Point P has coordinates 12, 5. The first value is x and the second one is y, which means the dimensions of the triangle given along the x-axis from O to S, there is 12 units. Then along the y-axis from P to S, there is 5 units. So we have the two sides given from the coordinates of point P. And immediately I can see that the line OP can be calculated using the theorem of Pythagoras. That will give me the line OP. Then I'm going to need trigonometric ratios to answer the questions given. Then number 1.2, it's very amazing to see how similar these questions are. And once you master these ideas, there is no way. Trigonometry must be one of the easiest sections to do in paper 2. So we have reduction formulas. If you see 180 degrees plus or minus theta, and the multiples of 180, which means I can multiply 180 by 2 to give me 360. 360 plus or minus theta, these are reduction formulas. So in this case, the 180 falls away to give me plus or minus theta. The 360 falls away to give me plus or minus theta. The only catch, the only one item that you must make sure you remember is that once you drop the 180, once you drop the 360, the remaining angle is going to be a positive or a negative depending on the cast diagram. Let's say, for example, I have the sine of 180 degrees plus theta. There is no any serious thinking required here. I must know immediately the 180 falls away. This is definitely going to be sine theta. The one task that I have is to check whether the sine theta is positive or negative. Please do check. If the sign is wrong, your answer is definitely going to be wrong. So if I have forgotten the cast rule by any chance, get your calculator. Type sine 180 plus. In place of theta, put any number which is less than 90. Let's say 1. Then type on the calculator the sign of 180 plus 1 and check the answer. If the answer is negative, it means you must have a negative sine theta. If the answer is positive, you must have a positive sine theta. You can check using a calculator. Then other expressions where sometimes learners forget, maybe because of pressure. Let's say I have the cos of 180 minus theta. This is supposed to be a negative cos theta, but because there is a squaring here, the squaring makes it positive again, because it will be a negative times a negative. Remember those kind of things. Reduction formulas are always a part of our calculation. So in question 1.2, the 360 falls away, the 180 falls away. I'm going to use the reduction formulas for those two expressions. Then apart from reduction formulas, also comes cofunctions. And they are always together. They are very good cousins. Cofunctions are now 90 degrees plus or minus theta. If an angle is added or subtracted from 90 degrees, then I apply cofunctions. So now cofunctions work like this. The 90 degrees falls away. There are two things that happen when you're working with a cofunction. The 90 degrees falls away, and then sine changes to cos, and cos changes to sine. So the answer to this expression is equal to the cos of theta. Now, one cofunction that learners forget a lot is the cos of 90 degrees plus theta. This one specific one, the 90 falls away, the cos changes to sine, but it becomes a negative sine theta. When we mark examinations, we notice that learners forget this negative a lot, and that messes up your marks. Reduction formulas. Number 1.3, number 1.3 and number 1.1 are in the same category. I may need to know how to work with the diagrams to simplify this kind of expressions. Cos 42 degrees is equal to root x. I can quickly draw a diagram. That's one of the options you can have. Draw a 90-degree triangle, then put 42 degrees in one angle. Then the other one, since the angles in a triangle must add up to 180, then the other one must have 48 degrees. Then this is cos. Cos is adjacent of hypotenuse. It means that adjacent in this triangle for 42 degrees is root k, and the hypotenuse is 1. Then we calculate the third side using the theorem of Pythagoras. So once we make a triangle like this, we have more information that we can use to answer question number 1.3. Number 1.4, very nice there. I have an expression where there is a sine followed by cos, then cos followed by sine. If you see trigonometric expressions following each other like this with a plus or minus, then I must know for sure that this one is a compound angle, and it is particularly a compound angle for sine. So you can think of the sine of A plus B or A minus B. If your expression has got cos and another cos, then sine and another sine, it is also a compound angle, but it is a compound angle for cos. So this is cos A plus or minus B. Identifying them is important, so that when I'm answering questions, I don't guess, try to work it out. It doesn't work out, try again. Once you do that, you start getting frustrated, and once you're frustrated, now you make more mistakes. The angrier you become or the frustrated you are, the more mistakes you make in an exam. It is necessary to learn to be in a relaxed position. Then determine the values of x for which the expression is undefined. Undefined simply means equate the denominator to 0. That's how we determine the undefined one. Equate the denominator to 0. After equating to 0, You then solve the resulting equation for x. These are the general ideas that are in this particular in these questions from the GDE 2023 Mathematics Paper 2. Now, let's look at how we can go ahead and answer these questions. If you look at this paper and other papers that I've posted, we see that the questions in trigonometry are very, very similar. So if you study the ideas very well, you stand a very good chance of passing this section. And it's worth a lot of marks in paper 2. So it is absolutely necessary to make sure we have a good understanding of the section of trigonometry. Right, number question 1.1. When given a triangle in this form, the coordinates of point P given here, the first value is the x and the second value is y. Those two numbers, they give us the dimensions of the triangle. So the line O to S is equal to 12 and the line PS is equal to 5. Now, that allows us to now determine the value of line from O to P. The line OP, when given two sides in a right-angled triangle, we can calculate the third one using the theorem of Pythagoras. So that means the value of OP using the theorem of Pythagoras is the square root of 12 squared plus 5 squared, which is equal to the square root of 169. The square root of 169 is equal to 13. So OP is equal to 13 units. Now, from there, it becomes straightforward now, determining the answers for all the expressions given there. I want to find the value of tan theta. We know from trigonometric ratios that the tan of theta is equal to opposite over adjacent. So the opposite to theta is 5, the adjacent is 12, the answer is 5 over 12. Number 1.1.2, I want to find the sine of theta. We know that the sine of any angle is equal to opposite over hypotenuse. The opposite to theta is 5 and the hypotenuse is 13. Therefore, the value of sine theta is equal to 5 over 13. Number 1.1.3, now this one I need a little bit of some thinking. I'm told that the line TO is equal to 19.5. So 19.5 in place of TO. Then connect point T to the x-axis to produce a right-angled triangle. Let's say the right-angled triangle is TOB. I'm just putting a label there for convenience purposes. From the coordinates of point T, line OB is equal to A, line TB is equal to B. So we have a right-angled triangle that has got measurements A and B, and the hypotenuse is equal to 19.5. We need to be reminded that in trigonometry, when working with a triangle which is in quadrant 2, 3, or 4, let's say I have a triangle in quadrant 2 where the measurements are given as x, y, and r, and I want to find the trigonometric ratios. The angle is measured from the positive side of the x-axis. So this angle from the positive side of the x-axis is theta. So now I can say cos theta, tan theta, sine theta. But important here is that the angle starts from the positive side of the x-axis, measured in an anti-clockwise direction. Now in this diagram, if you do the same thing, from line OS, which is the positive side of the x-axis, the angle for a triangle here is going to be 90 degrees plus theta. That is the size of the angle, because one part is theta, the other part is 90 degrees. So for the triangle that I have in quadrant 2, I have a triangle that has got the hypotenuse TO given as 19.5, and I want to find A. A is the adjacent. So if you are given the hypotenuse and you want to find the adjacent, then you can use cos to determine the adjacent. The cos of 90 degrees plus theta is equal to adjacent. The adjacent is A divided by the hypotenuse. The hypotenuse is 19.5. Then from here, we know that the cos of 19 plus theta is a cofunction. So that one we can express it as the sine of theta, negative sine theta. This is equal to A divided by 19.5. Then after that, you cross multiply to get the value of A. A is equal to negative of sine theta multiplied by 19.5. Then from our previous calculation in 112, we have calculated the value of sine theta. It is equal to 5 over 13. So we can say 5 over 13 in place of sine theta. Then you multiply this by 19.5. The answer that we get from this calculation is the value of A. So A is equal to negative 7.5. That is the value of A. So in doing so, I have answered the question 1.1 using that is a diagram type question. So I need to quickly emphasize before I move on. If you get a triangle on the grid, let's say I have a triangle in quadrant 3 where I have got the measurements y, x, and r. This is a right angle triangle. The value of the angle is measured from the positive side of the x-axis. This is where theta is. So if I say the sine of theta is opposite over hypotenuse, I am referring to theta measured from the positive side of the x-axis. Then I can find my values from there. Going onwards, I can find cos theta, I can find tan theta. That is what we did here. We took the entire angle from line OS up to the line TO. That is 90 plus theta. Then we apply trigonometric ratios and carry on to solve it using cofunctions. That answers number 1.1 for 7 marks. Number 1.2. Now this one we have explained a lot about this idea. 360 degrees, 180 degrees, those are reduction formulas. If you see 180 my plus or minus x or the multiples of 180, then you must know for sure that you are working with reduction formulas. Then secondly, 90 degrees plus or minus theta, that's a cofunction. So that one sine becomes cos and cos becomes sine. Those are obvious things that we are supposed to know in our minds as we work out these calculations. So I'm going to apply the formulas one by one. Marks in trigonometry, they are not given to the quantity of the calculation. If there is 7 marks, it doesn't mean you are going to write an essay of 7 pages. No, marks are given to the application of formulas. So in this expression, the 360 falls away. I remain with the sign, the 2x. Then here, the 90 falls away, and sine is going to change into cos. Here, the 180 falls away. I am applying reduction formulas and cofunctions. So my answer going forward, if I drop the 180, I remain with the sine of 2x. The one task that you must please be careful with is that once we drop the 180, the 360, the resulting expression is going to be positive or negative, and I must make sure I put the right sign there. If I'm not sure, I can also check with a calculator. Then the next term, sine negative x. Negative angles are in the fourth quadrant. So the negative x becomes a coefficient minus sine x. So at the bottom here, sine 90 plus x now changes into cos x using cofunctions. Then the last term is 2 multiplied by cos squared x. Once again, this is 180 plus x, which is supposed to be negative after applying reduction formulas, but it remains positive because it is squared, as the square makes it positive. Now if you simplify, the negative and the negative are going to make it positive. I have a double angle here. It only makes sense to say that this double angle here has to be changed using the double angle identities. What do we know about the double angle identities? We know that the sine of 2x is equal to 2 multiplied by sine x multiplied by cos x. This is coming from the double angle. Then I have got sine x there, which has already been there. This is all divided by the cos of x. Then plus 2 multiplied by cos squared x. That is my expression. Look at how cute this is going forward. Normally, once you apply reduction formulas, the question itself will lead you to the answer. So here we can safely divide cos divided by cos. Then simplify the remaining expression after we have divided cos out. So if you simplify, this will give me 2 multiplied by sine squared x, then plus 2 multiplied by cos squared x. Now, if you hear sine squared x plus cos squared x, that must remind us of that identity we do in grade 11. Cos squared x plus sine squared x is equal to 1. So to apply that identity, we use the factorization. If you factor out 2, then you're going to have sine squared x plus cos squared x is equal to 1. So this now gives us 2 times 1, and the answer eventually to this question is equal to 2. I have answered question number 1.2 by applying reduction formulas, negative angle cofunctions, then followed by a double angle. I must be able to do something like this for 6 marks. So what do we learn from number 1.2? We need to be sure about how to apply reduction formulas. So it is vital for me to know that if an angle is added or subtracted from 180 degrees or the multiples of 180, then the 180 falls away to give me plus or minus theta. And I must check to make sure that the sign that I put there is correct according to the cast diagram. If I can't remember, I can use a calculator to check. If you're using a calculator, you put a number in place of theta. Let's say I want to check the sine of 180 plus theta using a calculator. Put any number of your choice in place of theta. Let's say 1. Then you are going to see that this will become sine 180 plus 1. You check on the calculator the answer. If the answer is negative, then it means this must be negative theta. If the answer is positive, then it must be positive theta. So reduction formulas cannot go wrong because we can check them using a calculator. All right, question number 1.3. Right, this one is a very cute question. We have the cosine of 42 degrees is equal to root the square root of k, and then the question says you need to find what is the value of sine squared 69 degrees. Now we need to find out what is the relationship between 42 degrees and 69 degrees. And the idea that is being tested here is that of cofunctions. Now, if you remember cofunction, the cos, if I get this, let's start with the sine. The ideas of cofunctions. The cofunction is multiplication, addition or subtraction to 90 degrees. That is the idea of cofunctions. Now, we know that in cofunctions, the sine of angle theta is equal to the cos of 90 degrees minus theta. This is cofunction. Now, let's say theta is equal to 69. Then we can say that the sine of 69 degrees is equal to cos of 90 degrees minus 69 degrees. And we know that 90 minus 69 is equal to 21. Therefore, the sine of 69 degrees is equal to cos 90 minus 69, which gives us cos 21 degrees. So sine 69 is equivalent to cos 21. That is a relationship. It's important to be able to establish such relationships. Now, with that in mind, how can we get 21 from what we have? If you look at the 21 that I have here, the angle that we are given is the cosine of 42 degrees. The cosine of 42 degrees, 42 is the same as the 21 times 2. So I can express this as the cos of 2 multiplied by 21. Then using the ideas of double angle identities, this is the same as 2 times cos squared 21 minus 1. This is the value of cos 21 that is coming from cos 42 by application of double angle identities. Then we have established previously that cos 21 and sine 69, they are equal to each other. So what we are going to do now is that we are going to remove cos squared 21 and in that position put sine squared 69. That is substitution, because sine 69 and cos 21 are equal to each other. Then we do substitution. The cosine of 42 from the information provided is equal to the square root of k. So we substitute cos 42 with the square root of k. So the square root of k is equal to 2 times sine squared 69 minus 1. Then from there, we can make sine squared 69 the subject. That is what the question wants us to do. So that means root k plus 1 is equal to 2 multiplied by sine squared 69 degrees. Then we divide both sides by 2. We also divide here by 2. It will give us an expression, the square root of k plus 1 all divided by 2 is equal to sine squared 69 degrees. And that answers the question 1.3. So this one is a bit tricky. We need to know very well how to establish connections between given angles. On the same idea, we may need to remind you something cute. We also need to know that in general, the answer is done. I'm just explaining something else using the same question. If we say the cos of 42 degrees is equal to k, this sentence carries with it a, a lot more information. Now, if you draw a triangle, put 42 degrees, angles in a triangle add up to 180. So if one angle is 42, the other one has to be 48 so that the total can add up to 180. The cosine of an angle is adjacent over hypotenuse. So the adjacent to 42 is the square root of k. This is k over 1, therefore the hypotenuse is 1. Then the third side of the triangle, we can determine that one using the theorem of Pythagoras. Then we have got a triangle. From this triangle, we are able to find more information. We can get the value of sine 42. The sine of 42 is equal to opposite of hypotenuse. That's the square root of 1 minus k. From the same triangle, we are also able to get the value of tan 42. Tan is equal to opposite over adjacent. The opposite is the square root of 1 minus k, and the adjacent is the square root of k. From the same triangle, we are also able to get the sine of 48 degrees. The sine of 48, sine is opposite over hypotenuse. It's going to be the square root of k. We are also able to get the value of cos 48. Cos is adjacent of hypotenuse, so the adjacent to 48 is the square root of 1 minus k, and the hypotenuse is equal to 1. And we can also find tan 48 and so on. Now, if you look at this expression that I've written down here, they were not given there, but they are all contained in one sentence, which says cos 42 degrees is equal to k. There is a very good chance of getting expressions like this in your maths paper. You need to know how to work with them. And interesting as well, if you look at these expressions I've written here, the sine of 48, this one here, sine 48, and the cos of 42, we can see here that the cos of 42 is equal to root of k, and also the sine of 48 is equal to the square root of k, because these are co-functions. They give the same value. If you are to quickly maybe want to prove it, or just for more understanding sake, if you were to get the sine of 48, you can express this as equal to the sine of 90 degrees minus 42. Then you now have your co-function. You can change this to the cosine of 42 degrees. That is why the cos of 42 degrees and the sine of 48 degrees are equivalent to the cosine of 42 degrees and the sine of 48 degrees. They are equivalent to each other. It's because of co-functions. So I've said a lot. Number 1.3, I know it's for 3 marks, but in this case, I'm just using the same question. Right, the last part of this question is 1.4. We are given an expression, an identity there in 1.4, and we need to prove that identity. So you're studying, like as I always mention, when you are going through a past examination paper, do not waste time focusing on one particular question, because the questions are not going to be repeated unless maybe some psychiac or so, some sangoma or prophet told you that this question is going to be in the exam. Then you're gonna be focusing on that one particular question. Otherwise, when you are doing maths, pay attention to the details of the concepts. What are the ideas that are being tested by that question? So in question number 1.4, this is on compound angles. The question that one may want to ask, how do you know that they are compound angles? That is what is important, because I must be able to identify them. Now, compound angles. Look at your expression. If you see an expression where it starts with cos followed by another cos, then plus or minus, sine, and another sine, then this is definitely a compound angle for cos. So this is cos A plus plus and minus angle B. What I need to do now is to check and see that the angles are the same. So if the first one is cos A, the next one must be cos B. The first one is sine A, the next one must be sine B. Then I can see that this one here is the compound angle for cos. If you get an expression where you've got sine followed by cos, then you've got cos followed by sine with a plus or minus in between, then you must know also that this is a compound angle for sine. This is sine A plus or minus B. That's how I identify them. So when I look at my expression, I can see exactly that. Look at number 1.4. The first one is sine, the next one is cos. The next one is cos, the next one is sine. That means it's a compound angle identity for sine. Now, if you let angle 5x be A, 3x be B, 5x be A, and 3x be angle B, then it's going to be sine A cos B cos A sine B. We can change that into the sine of A minus B. Our A is 5x and our B is 3x. So this is the sine of 5x minus 3x, then divided by the tan of 2x. Tan is a fraction. So if you change tan to sine over cos, you are going to get a fraction on top of another fraction. In that case, I advise, it's not a requirement, but it may make our expression a bit simpler if we change the division line into a division sign. So the expression that says sine 5x minus 3x, that will give us sine 2x. This over, I'm going to change that one to divided by. Then tan is the same as the sine of 2x divided by the cos of 2x. Then we know from division of fractions that if you divide fractions, we change the division to multiplication, and then we swap the terms of the other fraction. So this fraction is going to become cos 2x divided by the sine of 2x. So my expression is the last term is -1. So there is -1 in each part here that I almost forgot. Then I carry on to simplify. The sine 2x is going to divide that sine 2x, and that will give me the cosine of 2x minus 1. To make my identity look the same as given, I have to change the cosine 2x using double angle identities. It will be 1 minus 2 times sine squared x, and then minus 1. 1 minus 1 is equal to 0. Therefore, the answer to this question is minus 2 times sine squared x. This is what we have on the right-hand side of my identity. The identity has been proven. That is compound angle identities. It is absolutely necessary to make sure we know how to identify compound angles. Then number 1.4.2, undefined. If you see anywhere where the question says for which values of x is the following undefined, Then you equate the denominator to 0. After equating the denominator to 0, you solve the equation for x. That is what we do. You equate the denominator to 0 and solve for x. So in our case, we can equate tan x, the tan of 2x to 0, and that will give us x is equal to 0 degrees. Then we have found the values of x for which the identity is undefined. Tan x, tan 2x is also undefined if the angle is equal to 90. If you remember from trigonometric functions, the asymptotes for tan. So we equate 2x to 90, and that will give us x is equal to 45 degrees. Because at 90 degrees, that is where the asymptote is. Tan is undefined at that point. That answers question number 1.4.2. Right, a quick summary of this particular examination paper focused on number 1.1. You are given a diagram, and please take note, in some cases they can ask you a question that requires you to draw your own diagram. We do have a video that we explained the diagrams. If you can go through that one, it may help. So we label our diagrams using the points that are given, calculate the third side using the theorem of Pythagoras, and then we can read numbers from the diagram. That is mainly the question number 1.1. Number 1.2, we need to be reminded of reduction formulas. So if I get 360 is 360 degrees plus or minus theta, then I must know for sure that the 360 falls away. I'm going to remain with plus or minus theta. If I get 180 plus or minus theta, the 180 falls away. I remain with plus or minus theta. I must then make sure that the resulting expression is positive or negative, and I must check that the sign is correct for that one. Then I must remember my co-functions. So these ones, they fall under reductions. Then I must remember my co-functions. So my co-functions in this case are 90 degrees plus or minus theta. I must remember this one. The 90 degrees falls away, then cos changes to sine, and sine changes to cos. And I must remember one which is very much forgotten very easily, the cos of 90 degrees plus theta. So this one changes into a negative of sine theta. Most of the time, learners, they forget the negative sign for some reason. And remembering that in the reduction formulas, if it's squared, then it must give you a positive number because the negative is squared to positive. Then what else do we have here? How do you identify a compound angle in any expression? That's number 1.4. And we said that if your expression is the same angles, but one is cos cos followed by sine sine, then you must know that this one is connected to the cosine of A plus or minus B. This is a compound angle for cos. If your angle is a sine cos and then cos sine, then you must know that this is the compound angle for the sine of A plus or minus B. Those are my compound angles. The double angles are easy to see because when you look at them, you are able to see that an angle has been multiplied by 2. Then another one is number 1.3. Number 1.3 is slightly hidden. We need to be very much careful. This one is co-functions. I normally say the sine of A, this is not an official formula, it's just me trying to put it in a simpler way. The sine of A over the cos of B is always equal to 1 if A plus b is equal to 90 degrees. This is cofunctions, which means should it happen that I get an expression like the sine of 25, for example, divided by the cos of 65. If we add 25 plus 65, they give us 90. So the answer to this question must equal to 1 because these two expressions are equivalent according to cofunctions. And the working out will be the sine of 25 is the same as the sine of 90 degrees minus 65 degrees. Then if I subtract from 90, it becomes a cofunction. So it is the same as the cos of 65 degrees. Then cos 65 divided by cos 65 will definitely give me 1. So this is trigonometry. If you look very closely at the questions in trigonometry, all past examination papers, you are going to notice that they are very much similar to each other. So much that if you really go through the concept very well, you stand a very good chance of getting good marks here because it's not complicated. Some questions can be tricky, obviously, but if you focus on the ideas and concepts behind the questions, then it will be very much easier for you.